As high-performance computing systems continue to grow and grow, our understanding of them shrinks. It's universally recognized that there's a lack of comprehensive data that can be used to improve the reliability and efficiency of these platforms. In response to this need, the computer science researchers at Sandia National Laboratories have developed LDMS, or Lightweight Distributed Metric Service Software.
So one of the things that's long been recognized is the lack of data, the lack of high fidelity data, the lack of synchronized data makes it impossible to do analysis that gives you insight into what's going on in the system. If you don't have enough data points in time, then you can't resolve what's going on. If you don't have coordinated points in time, you can't correlate events across the system. So one of the things that LDMS brings to this is that we now have this new source of data that we didn't have before on fidelities with details that we didn't have before. And that's allowing us to do new techniques of analysis to find out things like how can we characterize what's going on in the network. So we're looking at statistical techniques, we're looking at graphical techniques, we're developing new methods of visualization to handle the size of this data.
Other things are we've actually here at Sandia been able to look on our large-scale clusters, which are order of 1,000 nodes, a little bit more, but look at new features that users didn't know existed. So what kinds of things with respect to congestion, contention for shared file systems, memory imbalance, and things like that are actually impacting the performance of their applications and presenting large variability to those applications. So we're able to now present that data at 1 second intervals and enable them to understand what's actually going on, whereas before they could not.
These snapshots offer insight into how computer resources are being utilized, stressed, or depleted. For systems administrators, LDMS provides near real-time data for resources allocation and scheduling. For developers, it provides application execution support that can improve runtime performance. And for the high-performance design community, it provides valuable information about future designs.
There's hundreds of metrics that they're collecting on a time scale that they were never able to collect before, which gives them visibility into the performance and behavior of the system that they never had before. So that's the beauty of it.
One of the things that we're just exploring right now is congestion in large-scale platforms such as NCSA's Blue Waters. So it's a 27,000 node system. And so it's got this big network that interconnects all of the nodes. Understanding how congestion evolves, how applications interacting with shared resources like the network, like the shared file system, cause that congestion, and how you can schedule things to minimize that, then can maximize your performance.
We're actually providing this data in real time, so we can actually look at how the I/O performance of a job is progressing, each at the node level or as an aggregate level, as the job is running within the last 60 seconds or so of data. And this gives sometimes users an idea, is the job starting up correctly? Is it behaving as expected? Is it running slowly? Being able to provide real-time data is something I believe is unique to large-scale systems.
LDMS is freely available as open source software that is platform independent, so it can run on an IBM, Cray, or Linux clusters. And its computational overhead demands are so low it has no impact on application performance.
There are a lot of new uses for this data in the research arena. It's recognized that on these systems, as they get bigger, as they get more complex, it's no longer possible for a human to intervene and do things like do the control, do the adaptation. So we're doing machine learning techniques and autonomous reactions to the data.
We can now monitor large-scale systems and provide information for not just the users of the current systems, but for architects designing the next generation systems to build better systems that are more matched to the kinds of applications that we're running. And that wasn't possible before.
It's the best solution right now because it's the only solution. Right? There's no other product that will allow you to collect data at this scale without having any impact on the application.